In the vast, star-dusted theater of our solar system, there are countless worlds. We see giant planets wrapped in swirling storms. We find rocky worlds baked by a nearby star. And then, there are the moons, hundreds of them. They orbit their parent planets in a silent cosmic dance. Most are quiet, frozen relics of the solar system's birth. But some hold incredible secrets. One of these special places is a tiny moon, orbiting the magnificent ringed planet, Saturn. Its name is Enceladus. It is small, only about 500 kilometers across, so small you could fit it inside the state of Arizona. It is covered in brilliant white ice, making it one of the most reflective objects in our entire cosmic neighborhood. For a long time, we thought Enceladus was just another piece of frozen rock and ice, a beautiful but inactive world. We could not have been more wrong. Our journey to uncover the secrets of Enceladus begins with a remarkable machine, a robotic explorer named Cassini. This spacecraft was a joint mission between NASA, the European Space Agency, and the Italian Space Agency. It was one of the most ambitious and complex missions ever sent into deep space. Cassini's destination was the Saturn system. It was designed to spend years orbiting the gas giant, studying its rings, its atmosphere, and its fascinating collection of moons. Launched in 1997, it traveled for nearly 7 years across the blackness of space to reach its destination in 2004. It was our robotic eyes and ears, sent to a distant realm we could only dream of visiting. When Cassini arrived at Saturn, it began to rewrite the textbooks. It sent back breathtaking images of the planet's rings, revealing intricate structures and dynamic changes we had never seen before. It studied the giant moon Titan with its thick, hazy atmosphere and lakes of liquid methane. But among Saturn's many moons, little Enceladus started to stand out. At first, it was a puzzle. One of the first major clues came not from an image, but from Cassini's magnetometer, an instrument designed to measure magnetic fields. As the spacecraft flew past Enceladus, the magnetometer detected a strange disturbance. Saturn's powerful magnetic field, which extends far out into space, was being draped and diverted around the moon in a peculiar way. This suggested Enceladus had a significant atmosphere, one that was interacting with the magnetic field lines. This was a shocking discovery. The next clue came from studying Saturn's magnificent but faint E-ring. This is the widest and outermost of Saturn's main rings. When Cassini mapped the ring's structure, it found that it was thickest and densest right at the orbit of Enceladus. The connection was undeniable. This tiny moon was somehow spraying a plume of icy material into space, feeding this colossal ring. All these pieces of evidence, the magnetic field disturbance, the water vapor atmosphere, and the link to the E-ring, pointed to a single, extraordinary conclusion. Enceladus was not a dead world. It was an active one. The scientific team behind Cassini knew they were onto something huge. They had to get a much closer look. They decided to adjust Cassini's trajectory for a daring low-altitude flyby, aiming to pass directly over the South Pole to see what was there. On July 14, 2005, Cassini made its fateful approach. Hurtling through space at thousands of kilometers per hour, the spacecraft precisely executed its course correction. It swooped down over the southern hemisphere of the tiny icy moon. The first images to arrive were of the South Polar terrain. They were unlike anything seen before in the solar system. Instead of the expected landscape of ancient overlapping craters, this region was youthful and dramatically scarred. It was covered by a series of long parallel fractures etched into the ice. These features were immediately nicknamed tiger stripes. Thermal instruments on Cassini measured the temperature of the tiger stripes, and what they found was astonishing. While most of Enceladus's surface was a frigid minus 201 degrees Celsius, the stripes were significantly warmer. The definitive moment came a few months later, in November 2005. The Cassini team had devised a clever observation strategy. As the spacecraft flew past Enceladus, it would turn its cameras back towards the moon's dark side. What they saw exceeded all their wildest expectations. It was a discovery that would be printed in science textbooks for generations to come. There they were. Not faint, wispy tendrils, but dozens of brilliant fountain-like jets of ice and water vapor erupting from the South Polar region. Seeing the plumes was one thing, tasting them was another. The Cassini team realized they had an unprecedented opportunity. If they could fly the spacecraft through one of these plumes, they could use its sensitive instruments to directly sample and analyze the composition of the ejected material. Starting in 2008, the spacecraft made several of these incredible passes, some at altitudes as low as 25 kilometers above the moon's surface. As expected, the INMS confirmed that the vapor was overwhelmingly composed of water, but it found much more than just water. It detected significant amounts of simple organic compounds, carbon-based molecules like methane, propane, and formaldehyde. The Cosmic Dust Analyzer added even more astonishing details to the story. It discovered that the ice grains contained salt, specifically sodium chloride, common table salt. Even more remarkably, the CDA detected tiny nanoparticles of silica, essentially microscopic grains of sand. On Earth, silica grains like these are formed in one specific environment, in hot alkaline water under high pressure. This was the strongest evidence yet for active hydrothermal vents on the floor of Enceladus's hidden ocean. On Earth, hydrothermal vents are teeming with life, ecosystems that thrive in complete darkness, independent of the sun's energy. For astrobiologists, Enceladus is like hitting the jackpot. It possesses the three key ingredients that scientists believe are necessary for life as we know it. First, there is liquid water. Second, there are the essential chemical building blocks. The third and final ingredient is a source of usable energy. Enceladus appears to have all three ingredients in one convenient, accessible package. This makes Enceladus arguably the single most compelling place in our solar system to search for present-day life. When we talk about ocean worlds, another name quickly comes to mind: Europa. However, Enceladus presents a compelling case that, in some ways, makes it an even more tantalizing target. The most significant difference is the proven, ongoing activity. The discoveries at Enceladus and Europa have really opened our eyes to a new class of celestial body, the ocean world. Our own solar system appears to be full of them. The next great adventure in planetary science must be a return to Enceladus, armed with the specific goal of searching for the signs of biology within its plumes. Several missions have already been proposed by scientists and engineers, each more ambitious than the last. An even more thrilling possibility is a mission that would land on the surface. Imagine a robotic lander touching down on the pristine snowy terrain near the South Pole. The most audacious dream is a mission that could one day access the ocean directly. This could involve a cryobot, a probe that would melt its way through the kilometers of solid ice shell. Once it reached the ocean, it could release a submersible, an autonomous underwater vehicle that would swim through the dark alien sea. The story of Enceladus is more than just a scientific tale of a distant moon. It is a story about curiosity, exploration, and the human spirit. It speaks to our innate desire to look up at the night sky and wonder what is out there. For all of human history, we have asked the question, are we alone? Enceladus has given us a clear and compelling direction in our quest to find an answer. This tiny moon serves as a powerful reminder that our universe is filled with endless possibilities. It has taught us that we should expect the unexpected, that our assumptions about how worlds work can be overturned by a single stunning observation. The journey of discovery is far from over. The children of today may be the scientists and engineers who build the probes that finally answer the question of life on Enceladus. Ultimately, Enceladus leaves us with a feeling of awe and a sense of our place in the universe. It is a beacon of hope in the search for life, a world that invites us to return and continue its story. Until we go back, Enceladus will remain a shimmering, enigmatic jewel in Saturn's crown, a constant reminder of the secrets that lie hidden in the darkness, waiting for the light of human curiosity to reveal them. The universe is waiting.